But so how do you replace that? And that's exactly what happened next. So in the 1980s, Dr. Yoshino here, he started working on trying to figure out ways to replace the lithium metal. And he started looking at different types of carbonaceous materials. And he found out that certain qualities of, for example, petroleum coke, as you can see here to the left, when you treat it in the right way, also contains this kind of layered structure where you have gaps where lithium ions can go in and out. And furthermore, this material, these carbonaceous materials, had a fantastically low potential compared to lithium. So when you put this together, this material together with Goodenough's cathode material, you can maintain a fantastically high voltage in this particular battery of 4 volts. And this, what you see here, this is the configuration that we have in the modern days lithium-ion batteries. So the way it works is that you have 2 electrodes. Both of these electrodes are materials which can take up and release lithium ions at different potential. So what happens here is that during discharge, you have lithium ions going from one material across the electrolyte and into the other material. And at the same time, you can see that the electrons are passing through the circuit, driving your electric device. And this makes it very safe, because here you don't have any trace of lithium metal. So it makes it much safer. And also, what is very important here is that you can turn this process around. So if you plug this battery into a power source or a charger, you can reverse the process and you can recharge the battery. And of course, this process you can do many, many, many times, hundreds of times before the battery actually degrades or loses its capacity. So you can see that these discoveries really led to the development of a fantastic product, the lithium-ion battery. And as you can see on the next slide here, we have found applications, this type of battery has found applications in many, many, many instances. And you can see everything from small mobile electronics, if nothing else, not the least the mobile phone you have there in the middle that we're all using all the time, every day. Most of us at least. But also larger objects like vehicles, electric vehicles like bicycles and cars and other things. But as you can see to the right here, it's also increasingly being used as a complement to power sources, energy sources that fluctuate over time, like solar energy and wind energy, for example. So you can see that this battery has had a dramatic impact on our society. And it's very clear that the discoveries of our 3 laureates really made this possible. So it's really been to the very best benefit of humankind. So by that, I just want to leave the word back to Secretary Hansson.
Thank you, Olof. Thank you very much.